Hello students, today we'll discuss IB Physics HL paper 2, May 2017, time zone 2. My name is Nariman Melim, I am located in Baku and here you can see my mobile and email. The main sources that you should use to prepare for exam are either main huge textbooks from Oxford 2014 or short textbook from Tim Kirk, again Oxford 2014. But for sure you should have the following publications from examiner: IB Physics Guide 2016 with syllabus and booklet formulas, and for sure even for this video you should have Physics Data Booklet First Assessment 2016 with formulas. This booklet will be available for you at the exam, so beforehand you should know these formulas very well. So this exam is 8 questions for 2 hours 15 minutes. Let's look at the cover page. So a calculator is required for this paper. A clean copy of the physics data booklet is required for this paper. Let's start. Question 1. A glider is an aircraft with no engine. To be launched, a glider is uniformly accelerated from rest by a cable pulled by a motor that exerts a horizontal force on the glider throughout the launch. A. The glider reaches its launch speed after acceleration for 11 seconds. Assumes that the glider moves horizontally until it leaves the ground. Calculate the total distance traveled by the glider before it leaves the ground. So we assume the glider moves at constant acceleration. For this we use section 2.1. Given is u, v, t, and s should be found, so no a. We choose formula out of 4 without a. Rewrite this formula for s and find answer to 3 significant figures. Why 3? Because minimum here is 3 significant, so we keep 3 significant figures. B. The glider and pilot have a mass. During the acceleration, the glider is subject to average resistive force. Determine the average tension in the cable as the glider accelerates. Given mass, friction, resultant force equals mass times acceleration. Hence, resultant force at the same time is tension minus friction. Rewriting this formula for tension, we can find the tension, but we need acceleration. Formula for acceleration is by definition change of velocity divided by time. So velocity changes from 0 to maximum and time is 11 seconds. So we give answer to here with 4 significant figures, and then we put it into our formula for tension, but here we use 3 significant figures because mass is with 3 significant figures. So we round 1367 to 1370. Right, okay. C. The cable is pulled by an electric motor. The motor has an overall efficiency of 23%. Determine the average power input to the motor. So useful work done is actually here force times distance. Efficiency formula lets us to find total work in. So we divide not by percent, but we turn percent into decimal, 0.23, and we find the total work in. Average power actually will be total work in by time. So we find it in kilowatt. And again, we use 3 significant figures, so it is 8, 0 and 6. So instead of powers of 10 we use kilowatts. So one of the way to show significant figures. Let us read next question. After takeoff, the cable is released and the unpowered glider moves horizontally at constant speed. So this is the key word, constant speed. It means that forces should be balanced. The wings of the glider provide a lift force. The diagram shows the lift force acting on the glider and the direction of the motion of the glider. Direction actually has no meaning. What has meaning? The direction of the magnitude of lift. So another force is weight and drag force. Weight is downward, vertical, and actually I'm not right. Direction of motion is important because the drag force is opposite to the direction of the motion. And here we put 90 degrees. Right. So this is closed triangle. It means that forces are balanced. I don't know why in the Mach scheme they draw forces acting from the center of mass. So you can redraw it and put these two forces from the center of mass, and don't forget to label these forces, drag and drag. Let me take this. I can't take drag. I have it. Drag and weight. So labeled. Done. Next question. Outline the condition necessary for simple harmonic motion to occur. So this you should learn by heart. Force should be proportional to displacement from equilibrium position and directed in opposite direction to the displacement from the equilibrium position. So learn by heart. This is a very frequent question. A buoy floating in a vertical tube generates energy from the movement of water waves on the surface of the sea. When the buoy moves up, a cable turns a generator on the seabed, producing power. When the buoy moves down, the cable is wound in by a mechanism in generator and no power is produced. So we have vibration, half cycle we produce electricity, half cycle we don't produce electricity. The motion of the buoy can be assumed to be simple harmonic. A wave of amplitude so much, wavelength so much, moves with speed so much. Calculate the maximum vertical speed of the buoy. So actually here we have a vibration of the buoy up and down, and the wave moves some way forward at 90 degrees. But these motions are linked. So actually the amplitude of the wave is so much, wavelength so much, speed so much. So from 3,1 we can find speed for simple harmonic motion, amplitude of speed, but we should know the angular speed. So we should now see what is the frequency of the wave that pass by. So wave equation can be written for frequency. So frequency of the wave is so much. This means that angular speed for cyclic motion, simple harmonic motion, is 2 pi f, and this is radians second. Then we multiply angular speed that we found by amplitude of the wave, and we get the speed to two significant figures. Sketch a graph to show the variation with time of generator output power. Label the time axis with a suitable scale. First of all, as we know frequency, we can find period, because period is 1 over frequency, so it is 10 seconds. Also we know that half period we produce electricity, half period we don't produce electricity, and the speed is different. So variation will be half period we produce electricity, half period we don't produce electricity. Actually, the higher we move, so it's not about speed, the higher we move, the higher energy we have. So it goes up and down. During motion up and down, we produce output again with maximum. Finished. C. Water can be used in other way to generate energy. Outlined with reference to energy changes the operation of pump storage hydroelectric system. In pump storage hydroelectric system, we pump water to some height when electricity is not in demand. And potential energy of water is converted to kinetic energy of moving water and turbines. Electricity is generated in generator. Pump water back during night when energy cheap and energy not in demand. There is a surplus of energy. The water in a particular pump storage hydroelectric system falls a vertical distance to the turbines. Calculate the speed at which the water arrives to the turbines. Assume there is no energy loss. So no energy loss means increase of kinetic energy equals minus decrease of potential energy. Kinetic energy, change of kinetic energy will be half mv squared minus 0. And change of potential energy will be minus mg delta H. So we equate these energies, cross out mass, and without mass we solve it for v squared and then for v, and then substitute values of g and change of height 270 meters. G is 981 from data booklet. Finished. Next question, 3i. The hydroelectric system has four 250 megawatt generators. Determine the maximum time for which the hydroelectric can be maintained full output from the stored energy when the mass so much passes through the turbines. So 4 generators, each so much, produce 1000 megawatt. Power equals energy divided by time. It means that time will be energy divided by power. Energy will be energy of moving water, and we know the speed of the water and we know the mass, so we can find this energy. So as a result, we find time in seconds. We divide by 3600 and get the time in hours, 11 hours, to 2 significant figures. Not all stored energy can be retrieved because of energy losses in the system. Explain 2 such losses. Of course, sound and thermal. Sound in turbines and thermal in wires and components. Question 3. The electrical circuit shown is used to investigate the temperature change in a wire that is wrapped around a mercury glass thermometer. A power supply of EMF 24 volt and the negligible internal resistance is connected to a capacitor and to a coil of resistance wire using an arrangement of 2 switches. Switch S1 is closed and few seconds later open. Then switch S2 is closed. So when switch S1 is closed, capacitor is charged and gets the same voltage, 24 volt. Then we open the switch and we close the switch. Capacitor is discharging and current flows through the coil and it's heating it at the same time. A. The capacitance of the capacitor is so much. Calculate the energy stored in the capacitor when it is fully charged. Section 11.3. Energy of capacitor through capacitance and voltage. Voltage, as I told you, will be equal to voltage of EMF, and we get answer with 3 significant figures. Right, so this is the energy stored by a capacitor. B. The resistance of the wire is so much. Determine the time taken for the capacitor to discharge through the resistive wire. Assume that the capacitor is completely discharged when the potential difference across it has fallen to 0.24. So we assume that it is discharged. And what is given? Resistance. From section 11.3 we have formula for time constant and formula for how charge is changing having this time constant. To get rid of exponent we take logarithm of both sides, then we convert charge into CV, and we have, instead of ratio of charges, we have ratio of voltages, and then we use the information that the voltage after it is fully discharged is 0.24. It was 24, so time will be, with two significant figures, 8100 seconds. C. The mass of resistance Y is so much, observed temperature rise is 28 Kelvin. Estimate the specific heat capacity of the Y, include an appropriate unit for your answer. So mass we know, temperature change we know. From section 3.1, energy equals Cm delta T. Then C equals Q over M delta T. The energy of discharge we calculated in the previous one of the previous steps, 6.3 joules. Mass we turn into kilograms, and we have this specific heat capacity. I. Suggest one other energy loss in the experiment and the effect it will have on the value of the specific heat capacity of the wire. Some thermal energy will be transferred to surroundings, and as a result the specific value capacity obtained by student will be larger than the reference value or accepted value. Question 4. A student investigates how light can be used to measure the speed of a toy train. Light from laser is incident on a double slit. The light from slit is detected by a light sensor attached to the train. The graph shows the variation with time of the output voltage from the light sensor as the train moves parallel to the slit. The output voltage is proportional to intensity of the light. So what we have here? We have here double slit experiment. So on the path of the toy train we'll have fringes, and as a result we see such picture, output voltage. Explain with reference to light passing through the slits why a series of voltage peaks occurs. So light interfere, patterns consist of intensity maxima and minima, and voltage peaks correspond to interference maxima. B. The slits are separated. Laser beam has wavelengths. The slits are from the train. Calculate the separation of two adjacent positions of the train when the output voltage is at maximum. So section 4.4, different distance between fringes. So we substitute wavelength, distance to the screen, and distance between slits, and we get answer with two significant figures. Estimate the speed of the train. So I copied this picture here, and we see that during 100 milliseconds, 1, 2, 3, 4 fringe distances are passed. So speed will be 4 fringe distances will be 4 times 1 fringe distance, and speed will be distance over time. We give answer with two significant figures. As the train continues to move, the first diffraction minimum is observed when the light sensor is at distance 0.13 meter from the center of the fringe. Determine the width of one of the slits. As we observe minimum, So we have triangle, distance to the screen, distance to the minimum, and here angle. This angle is given by section 9.2, angle of minimum. This can be rewritten for width of the slit B. What we need to know angle. Angle is approximately equal to tangent, and tangent is 0.13 over 5 in radians. So we put these values here and we get answer to two significant figures. I. Suggest the variation in the output voltage from the light sensor that will be observed as the train moves beyond the first diffraction minimum. So beyond, average voltage will be smaller and minimum spacing will still be approximately the same. In another experiment, the student replaces the light sensor with a sound sensor. The train travels away from the loudspeaker that is emitting sound waves of constant amplitude and frequency toward a reflecting barrier. The graph shows the variation with time of the output voltage from the sound sensor, output voltage. So actually here we have one wave moving to the left, reflecting wave moving to the right. They interfere and they produce standing wave, and this is registered by the sound sensor. Standing wave, we have antinodes with maximum displacement and nodes with minimum displacement or amplitude. Explain how this effect arises. As I said, a reflection at barrier leads to two waves traveling in opposite direction. Standing waves are formed. Maximum correspond to antinode and minimum correspond to node. Question 5. The first scientists to identify alpha particles by direct method were Rutherford and Royce. They knew that radium decays by alpha emission to form a nuclide that known as radon. Write down the nuclear equation for this decay. So we write nuclear equation. For alpha particle we put proton number or charge 2, nuclear number 4. Then we balance top values and bottom values. For top values we have this equation from which we get x. For bottom values we have this equation for which we get y. After knowing all these values, we write the result. Finished. At the start of the experiment, Rutherford and Roy put so many moles of pure radium in a small closed cylinder. The cylinder is fixed in the center of a large closed cylinder. The experiment lasted 6 days. The decay constant of radium is so much. Deduce that the activity of radium is almost constant during the experiment. So activity is given by this formula after some time t. After t days, this coefficient is almost 1. As a result, activity is the same as before, almost. Shows that so many alpha particles still are emitted by radium-226 in 6 days. So number of moles can be turned to number of particles, atoms, and for a section 12.2, number of active elements after time t is given by this formula. Number of decayed nucleus or alpha particles is difference. So by substituting the value we can find how many decayed. So this value we will use later. At the start of the experiment, all the air was removed from cylinder B. The alpha particles combined with electrons as they moved through the wall of the cylinder A to form helium gas in cylinder B. The wall of cylinder is made from glass. Outline why the thin glass wall had to be very thin. Thin glass increases probability of outward particle crossing glass because alpha particles are very least penetrating, most ionizing particles, very low penetrating. The experiment was carried out at a temperature. The volume of cylinder was so much. Calculate the pressure of helium gas. Helium is a monoatomic gas over the 6-day period. So over this period, we know how many molecules, atoms were produced. We can find how many moles are produced. Using formulas from section 3.2 for gas equation, we rewrite it for pressure, and we only need number of moles. Temperature we change to Kelvin temperature, and everything, the rest is given. Finished. Question 5. Rutherford and Royd identified the helium gas in cylinder by observing its emission spectrum. Outline with reference to atomic energy levels how an emission spectrum is formed. Electron drops from high energy level to low energy level, and energy levels are discrete. Frequency of photon is related to energy change, and therefore is also discrete. The work was first reported in a peer-reviewed scientific journal. Outlined why Rutherford and Royd choose to publish their work in this way. Peer review guarantees the validity of the work and means that readers have confidence in their validity of the work. Here we have picture. The copper wire and insulator are both exposed to an electric field. Discuss with reference to charge carriers why there is significant electric charge only in the copper wires. When an electric field is applied to any material using a cell, etc., it acts to accelerate any free electrons. Electrons are the charge carriers in copper. Copper have many free electrons, whereas insulators have no or very few electrons or charge carriers. Here we have AC generator, cable, and electric rod. Cable consists of 32 copper wires with so much length. Each wire has so much resistance. The cable is connected to AC generator with this power, output power. A peak potential difference is so much. The resistivity of copper wire is so much. Calculate the radius of each wire. So section 5.2 resistivity formula we write for area, and we use 1 each wire. Each wire have resistance 64 ohm and 35 kilometers and resistivity, so we get the value. Then, knowing the area from formula A equals PR squared, we find R to 3 significant figures. Calculate the peak current in the cable. So for generator we have power equals current times voltage, current equals power by voltage, and we divide power by peak power by peak voltage, and we get the value with 2 significant figures. Determine the power dissipated in cable per unit length. Because we have 32 parallel connection of wires, the resistance will be 32 times less. It will be 2 ohm. Power divided by length will be I squared R divided by length. So I we found, we use more exact value with 3 significant figures, but we give answer to 2 significant figures. To ensure the power supply cannot be interrupted, two identical cables are connected in parallel. Calculate the root mean square current in each cable. Two cables in parallel means that the current through each is 2 times less. So current flows through two cables. So we divide by 2. This is peak value or maximum value. So this is not I total, it is current. So current through each. So current we know, this is peak value. We divide by square root of 2. This will be root mean square value. Root mean square value. D. Two cables in part C are suspended a constant distance apart. Explain how the magnetic force acting between the cables vary during the course of one cycle of the alternating current. So wires attract whenever the current is in the same direction. So every half cycle current changes direction, but they are always in the same direction. So we have attraction with maximum twice in each cycle. Question 6 continues. The energy output of the AC generator is at much lower voltage than the 150 kW use of transmission. A step-up transformer is used between the generator and the cable. Suggest the advantage of using step-up transformer. Higher voltage give lower current. Transformer formula. Energy losses will be decreased as a result. State how eddy current loss is minimized in transformer. The core is laminated, sliced into very thin slices. Question 7. Yellow light is incident on the surface of particular photocell. Calculate the wavelength of the light. Section 7.1. Formula for wavelengths found. Electrons emitted from the surface of photocell have almost no kinetic energy. Explain why this doesn't contradict the law of conservation of energy. So potential energy is required to leave surface. So all energy comes from photon, and nothing is left for kinetic energy. So energy of photon equals work function. Radiation, okay, let's B. Radiation of photon energy is now incident of the photocell. Calculate the maximum velocity of the emitted electron. So another photon, but we use this formula from section 12.1. Maximum kinetic energy equals energy of photon minus work function. For yellow light, kinetic energy appeared to be 0, so in this way we can find the work function. It will be equal to energy of yellow photon. For new radiation, we just find the kinetic energy. Then we use formula for kinetic energy to find expression for velocity, square root this expression, and then give answer to two significant figures. The photocell is connected to a cell as shown. The photoelectric current is at its maximum saturation current. Radiation with a greater photon energy than that in B is now incident on the photocell. The intensity of this radiation is the same as that in B. Describes the change in the number of photons per second incident on the surface of photocell. So intensity equals number of photon by energy of photon. It means that number of photon is inversely proportional to energy of photon if intensity stays the same. So light has higher photon energy, so fewer photons incident per second. State and explain the effect of maximum photoelectric current as a result of increasing the photon energy in this way. So because between photon and electron we have 1-to-1 correspondence, few electrons per second, so current smaller. Question 8. So Sun and Earth, so gravitational potential due to Sun at the surface is so much. The following data are available about Earth and Sun. Outlines why the gravitational potential is negative. Potential is defined to be zero at infinity. If we move from surface to infinity, we need to do work. As a result, so energy at the surface, so infinity is zero, we rewrite it and we get energy at the surface will be minus work done, and work is positive, so which is negative, so energy at the surface is negative. The gravitational potential due to Sun as the distance r from the center is Vs. Shows that RVS equals constant. Section 10.2 or actually formula for Vs rewritten give us RVS is Gm. G is constant, M is constant. It means that RV is constant. Calculate the gravitational potential energy of the Earth in its orbit around the Sun. Give your answer to an appropriate number of significant figures. Method 1. So we know V at the surface, and we should find V at some distance. So at Earth's position, R2 will be different. So we make this equation, RV constant, and then we find the value. Another method is just from constants. So Gm mr. So okay. 3i. Calculate the total energy of the Earth in its orbit. Total energy will be potential plus kinetic. Section 10.2 give us the orbit speed of Earth. If we rewrite this, it will be exactly equal to half potential energy. So we found how much is potential energy, and we divide by 2. So total energy will be kinetic energy minus potential energy minus 2.71033. 4. An asteroid strikes the Earth and causes the orbit speed of the Earth to suddenly decrease. Suggest the way in which the orbit of the Earth will change. Earth moves closer to Earth, new orbit with greater speed but lower total energy. Outline in terms of force acting on it why Earth remains in a circular orbit around the Sun. Centripetal force is required for circular motion, and it is provided by gravitational force between Earth and Sun. Paper is over. Thank you for your attention.